That was still pretty crappy. Welcome to Hands of Science. Why does a warm soda explode? Well, let's take a little trip and explain. So here's a nice free image I found on the internet of the Caribbean. I'm not exactly sure where it is, but it sure is beautiful. The water is clear. You can see to the bottom. There's no real life. There's no seaweed. Now here's a kelp forest off the coast of California, a lot murkier and a little less appealing looking, but teeming with life. All right. Why is that? Well, here we have two glasses, and in each glass I'm putting an exactly equal amount of water. 160 milliliters of water in each glass. Okay, now the one glass I'm putting in my freezer, next to next week's food and 5-year-old frozen veggies. All right. And here is a stage scene of a microwave counting down. However, I did eventually put the cup in the microwave before I did the experiment. So the warm one is now on the left. And as you can see, I'm putting spoonful after spoonful of sugar into that warm water. In fact, I end up going through the entire cup of sugar, and at some point, right about here, I go and get some more sugar. And I come back with it. It keeps dissolving. As you can see, the warm water rapidly dissolves the sugar. In a minute, I start to put some sugar into the cold water, and it doesn't. At first, it absorbs, it dissolves it pretty well. But even after just 2 spoonfuls, you start to have some precipitation of the sugar out of the cold water. Meanwhile, the warm water, I continue to dissolve more and more and more sugar. It eventually forms a syrup. So why is that? Well, there's a capacity for water to dissolve various substances, and when it comes to solids, as the water is warmer, it has a greater ability to dissolve the substances. As you can clearly see, the warm water dissolves far more sugar than the cold water does. There you go, one last bit. See, it really, at this point, the cold water just doesn't absorb. As you can see, the sugar stays out of solution. All right. The opposite situation occurs with gas. So here we have a cold soda. And as you can see, a little bit of the gas is escaping when I open it up. But now we have a room temperature soda, and it's not really very dramatic. It didn't really explode, but there certainly is a greater release of gas. Honestly, I was expecting a bit of a bigger reaction than that, but I think I know what happened. All right, so now we have a full sugar soda. The diet soda I don't think is as effective because in the regular soda you have both sugar and gas dissolved in the same volume of liquid. Therefore, it's even more difficult for the liquid to hold on to all that dissolved gas. Clearly, I cooled the one and warmed the other with hot water. The cold one there is on the right, and the warm one is on the left. Cold one is normal, however, the warm one is very wobbly because the escaping gas has actually distented the bottom of the bottle, so it's very wobbly. And as you can see, even that gentle shake has caused a bunch of gas bubbles to form. And no such gas bubbles form in the cold one. When they open up the cold one, nothing happens, just like you would expect when you have a normal soda. On a tight budget, so I will save that soda for later. Okay. So now we have the heated up soda, and when I open it, finally we're going to have our explosion. Not really, but hey, look at that. The gas really keeps on going and going and going and escaping, almost like it's boiling. Therefore, warm water, like the water in the tropical ocean, just cannot hold on to the oxygen and the carbon dioxide that life needs to sustain itself. And therefore, tropical waters are a desert, and therefore soda cans explode when they get too hot. Thank you for watching this episode of Hands of Science. If you enjoyed today's episode, please like and subscribe.